Okay, so now that we have our temperature solved, let's relate this to the actual density. And for that, I'm going to create a point triangle and let's set density. Now the density is going to be related to the temperature. Whenever we have a higher temperature, we should have a higher density. But another thing that I want to relate to the density is have kind of a ramp that allows me to control the density in terms of this direction, in terms of the x-axis. What I mean is the edges, the points that are closer to the edges should have lower density and should have the ones that are closer, that are more in the middle, will be subjected to a higher friction, and so they should have higher density. And that's pretty easy to do. We can actually deploy that first. So we can say that density is going to be equal to a channel ramp, so that we can actually control it. Let's call this ramp dense, and we'll use the bounding box. Let's actually calculate it first. So let's use a float. It's going to say b box p, and it's going to be equal to rel b box, and we'll say input 0 position, and then we can just grab the b box on the direction that we actually want. So p dot x. It's not a float, it's a vector. My bad. And now it should be okay. Now let's have a look at the density that we just set. Holding control, middle mouse button, and I'm gonna just press on this. So as you can see, this kind of expresses what we have here on this ramp. I'm gonna click on the first one, set interpolation to Catmull ROM, and I'll just make sure we have something more like this. Okay, so that way we have higher density on the middle and lower density on the edges. Okay, more or less symmetrical, it's fine. And next, what we want to do is we want to make sure that this value is actually going to be multiplied by the temperature. If we check the temperature values that we have so far, up to this point, the temperature is going almost up to 2, and it's probably going to go all the way up to 2 eventually. And we can set the density to be exactly the same amount, or based on the same values, or we can kind of just bring it down to half, and that way we're going to have a density that's going to oscillate between 0 and 1, while the temperature is going to be oscillating between 0 and 2. When we're setting up our source inside the DOP network, we actually have multipliers for this. So I'm going to leave it as is. So I'll use this ramp, and I'll also multiply it by the temperature that we have. Okay, so that way we actually have a relation between the density. So we're actually looking at density right now, and you can tell by the fact that the edges are always kind of blue. Okay, and the density is going to be increasing with the temperature as well. Okay, cool. So now we have the temperature, we have the velocities, we have the temperature, and we have the density. So we pretty much have everything we need to actually cache this out. And I'm going to create a file cache, and I'm going to save it on the geometry or maybe on the sim. Before actually pressing the save to disk, I'm then going to turn on the load from disk as soon as we calculate everything. Before that, I'm just going to increase the density. Right now we had lower density here on this scatter value, just so we had enough to visualize things faster while we were developing our system. So now I'm going to kind of duplicate this. Let's see how much density we have. Maybe even more. Let's go 16. Maybe 20,000. Yeah, I think this is enough. This should be enough. So the next step is going to be for us to just save to disk, and then we'll be good to go. I'll be right back as soon as this finishes. So it was pretty fast to calculate, and now we have the points One thing we can do is, and that might help as well, is actually apply some post-processing as soon as we have as soon as you have cached this, you can apply an attribute blur. And considering even though this is kind of fragmenting into 3 elements, considering the speed at which this is going to be rotating, this shouldn't be an issue. And it's just on during that moment where it's at top speed, it kind of breaks down there, but then it kind of comes back properly. Yeah, let's just have a manual multiplier. Let's create a point wrangle. Manual mult. And that way we can just times equals dense mult, and that way we can have more control over this. Let's say we start with the density of 0, and then it starts to increase. Let's say maybe I'm gonna have a look at the temperature right now. So as the temperature rises, let's say 24, we go to a multiplier of 1, and then the tire stops around here somewhere. So we can set another one here and just, so I'm holding Alt and pressing the number, and let's say 0. So now we have something like this. I'm going to hold Shift, click and drag, and use the middle mouse button to actually pull this a bit more. So if we look at the density now, we should see that we start at 0, and then it starts to multiply, and then it goes all the way back to 0. So even though we have a gradient growing from blue to red, in fact, the values that we have right now are already very low. Okay, let's just create a null, and this is going to be our out source points. So the only thing missing for us to actually have the source complete is going to be to have an attribute rasterize. And what we want to rasterize are density, temperature, and velocity. We'll set the particle scale to be 0.01. The voxel size also needs to be smaller. So here we can have a better idea of what's happening. Okay. It's looking good. If it doesn't work out, if it doesn't give us the results that we want, then we'll come back to this. But we'll try it with this one. So now we have our source ready. We can move on to actually work on the DOP network that's going to be generating our smoke simulation.